All right, so let's imagine, right? Imagine a philosopher who's not, stuck up in their ivory tower thinking these abstract thoughts, but who really wants to dive into the real world and like change things using, well, the tools of science and communication, visual communication even.
I like that. Yeah, and a good example of that kind of philosopher is Otto Neurath. He was a central figure in the Vienna Circle and a key figure in the Unity of Science movement.
Yeah, the Unity of Science movement. So in this deep dive, we're going to be going through the Stanford Encyclopedia of Philosophy entry on Otto Neurath, and it's a pretty dense entry.
It is.
But hopefully we can unpack some of his core ideas for you. I mean, especially his views on how philosophy, science, and society are all intertwined. Because really, why should any of us even care about this guy, this Otto Neurath, right?
Right.
Well, he gives us some really interesting perspectives on the nature of knowledge and how we can kind of achieve this scientific attitude. At least that's what he calls it.
He did call it that, yeah.
So, let's get started. Now, one of the first things that kind of jumps out at you when you read about Neurath is that he had this really strong vision for what philosophy should be.
Yeah.
And it definitely wasn't the kind of traditional armchair philosopher model that a lot of people think of.
Yeah, he wasn't a fan of that at all.
Not at all. So what was it about philosophy that he thought was so important?
Well, he was really convinced that the value of philosophy wasn't in some kind of isolated theoretical realm, like it was cut off from everything else.
Right.
It was more about being really embedded in this practical work that's done on, within, and even for science and society. Like philosophy is really involved, like a participant.
Right.
And he really challenged the idea of it being a separate discipline.
Okay, so he didn't want philosophy to be like this superior discipline. He wanted it to be almost like, working together with science, kind of like a partnership.
Yeah, more of a collaborative thing.
So not just thinking about science, but really being a part of the process. Interesting. Okay. So how did this idea of philosophy as a participant in science, how did that affect his view of, what science itself is all about?
Well, that's where it gets really interesting because he didn't believe that science just produced these fixed, absolute truths that are somehow, grounded in pure experience or something.
Yeah, like we can just observe the world and then boom, there's a truth, right?
No, he argued that there's always this inherent uncertainty in science, that we have to make decisions often with incomplete information, and that cooperation between researchers is really, really vital.
So it's not just about, some lone genius scientist coming up with the answer, right? It's
much more messy than that.
It's messier. It's about working together.
And changing your mind and working with others.
Okay, so much more dynamic than the traditional view of science. Now, underlying all of this, this view of science was his pretty unique philosophical perspective. So how would you characterize that, his overall worldview, I guess?
Well, he was a naturalist and a holist and a pragmatist.
Okay, a lot of ists in there.
I know, right?
Yeah.
But what it really means is that he thought that philosophy should investigate the conditions that make science possible, but not in some abstract way. He thought we should look at how science actually is, how it's practiced, all the physical, biological, sociological conditions that are involved. Look at the real world.
Okay, so looking at science in its context, in its full context, not
So
just
the ideas, yeah.
not just the abstract ideas.
Yeah.
And you mentioned that science, for him, was a fundamentally social and historical thing. That seems like a pretty, key part of his thinking.
Absolutely.
So what did he mean by that? What did he mean that it's social and historical?
Well, he really believed that science can't just be this isolated thing done by a few smart people.
Right.
It's not that.
Not some geniuses in an ivory tower somewhere.
Exactly. He saw it as fundamentally social and always connected to the historical context that it's happening in. So you can't separate thinking about society from thinking for society and thinking within society.
So it's all connected. The science that we do is always going to be influenced by the society that we live in.
And it influences society too.
And it influences society right back. And I guess that kind of leads into his view of what objectivity and rationality are all about.
Yeah, because he thought those were social constructs.
Okay. So not like absolute standards.
Right. They're not these preordained universal principles.
But instead, they come from.
Well, from our social interactions. The agreements that we come to, the norms that develop within a community, especially a community of scientists.
So even the rules of science, what counts as good science, that's determined by the community of scientists.
In a way, yes.
Huh. And so how did he actually, come to these ideas? What was his background? Where did all of this come from?
Well, his intellectual development was really, really broad. He had a huge advantage because he had access to his father's library when he was growing up.
Oh, wow. So he had all these books at his fingertips.
Yeah, and he was exposed to all sorts of different subjects, literature, math, physics, history, philosophy, economics.
Wow, that's a lot.
It is. But then, interestingly enough, he did his doctorate in economic history.
Economic history.
Yeah, and he focused on the non-monetary economies of antiquity, which is, that's fascinating in itself.
Yeah, so already thinking outside the box, right? Looking at a system that's very different from our own.
Exactly. And I think that kind of set the stage for his later thinking about different systems and taking these holistic perspectives.
Right, so seeing things as connected, seeing the bigger picture. Okay, so he gets his doctorate, and then what?
Well, he gets back to Vienna, and he's really involved in all the debates going on about the unity of science.
So the whole, are the sciences all connected? Are they separate?
Exactly. That was a big one at the time. And then also the role of values in science. Like, do our values affect the science that we do?
Yeah.
And then, of course, there were all the big questions in economics that he was interested in.
Right, right. And so he was, really engaged with all these big picture questions.
Oh, yeah.
About the nature of science, the nature of knowledge.
And how it relates to society.
Exactly. Okay, so those ideas are kind of brewing, right? But then, world events start to happen, and it seems like that had a big impact on his thinking, too.
Absolutely. He got a grant to study the Balkan Wars and then World War I.
Oh, wow. So he was actually there.
Yeah. And this led him to develop this whole theory of war economy.
War economy.
Uh-huh. And it was based on the idea that during war, the economy kind of reverts back to a natural non-monetary system. He called it an economy in kind.
So trading goods and services directly rather than using money.
Exactly. And he even thought about ways to apply some of these war economy ideas in peacetime, as a way to solve social problems.
Wow, so he was trying to take what he learned from this really intense situation of war and apply it to improving society in general.
Yeah, he was really committed to actually using his ideas, not just theorizing.
Right. And then, talk about getting involved in the real world. He actually ended up in a government position for a while.
It did, yeah. In 1919, he briefly became the head of the Central Planning Office in the Bavarian Socialist government.
Oh, wow. Okay. And how did that go?
Well, it was a short-lived government, unfortunately.
Yeah, sounds like it.
And he was dismissed from his academic post.
Oh, no.
But his time there, really shaped his ideas about economic socialization.
So he was really putting his ideas into practice there.
He was.
Trying to make a real difference.
Absolutely.
And all this time, his social concerns are really at the forefront of his thinking.
Yeah. He was really driven by this concern for the collective welfare, for everyone's well-being. He called it Epicurean socialism.
Epicurean socialism?
Yeah, it was his own unique blend of ideas, Not quite utilitarianism, but definitely focused on maximizing happiness for the whole community. And this practical engagement with socialist politics continued when he moved to Vienna in the 1920s, specifically Red Vienna.
Yeah, Red Vienna. That was a pretty incredible time and place, right?
Absolutely.
Yeah.
A hotbed of progressive thought and experimentation.
And Neurath was right in the middle of it.
Oh, yeah. From 1921 to 1934, he was deeply involved in the socialist politics there, particularly in areas like public housing and adult education.
That's right. And this is where he starts to develop his ideas about using visual communication for education, right?
Exactly. He founded the Social and Economic Museum in Vienna, where he pioneered what's known as the Vienna method of picture statistics.
Using pictures to communicate data. That's so interesting.
Yeah, it was really revolutionary at the time. And he developed this whole internationally influential visual language called isotype.
Isotype?
Yeah, for visual education. And it's amazing how these ideas still influence visual communication today.
Right. So he was really thinking about how to make complex information clear and accessible to everyone.
Exactly.
Okay, so all of this is going on. He's really engaged in these practical projects, but at the same time, he's also deeply involved in the development of the Vienna Circle.
Yeah, that's right.
So how did that all come about?
Well, in 1928, he was really instrumental in founding the Verein Ernst Mach. And then from that, the Vienna Circle was formally established in 1929.
Right. And their goal was to create a scientific world conception based on the principles of logical empiricism.
That's it.
Right. So logical empiricism was this really influential philosophical movement in the 20th century.
Yeah.
And Neurath was one of the key figures, but he also had some pretty unique views within that movement, right?
Oh, he did. I mean, he shared the general goals of the Vienna Circle, but his particular philosophical approach was a little bit different. He was really committed to physicalism, anti-foundationalism, holism, naturalism, externalism, and pragmatism.
Wow. Okay, let's break that down a little bit. I think we should probably start with physicalism, because that seems to be pretty central to his whole view.
It is.
So what did he actually mean by physicalism?
Well, for him, physicalism was this idea that the unity of science and its intelligibility and its objectivity all depend on using a language that talks about public things, events, and processes, things that are located in space and time.
Okay, so the language of science should be grounded in the observable world, the physical world.
Exactly.
Okay, but did he think that everything was literally physical, like in some metaphysical sense?
That's a good question. He wasn't really making a strong ontological claim about the nature of reality itself.
Okay, so he wasn't saying that everything is physical.
No, but he was saying that our best way to understand the world and talk about it scientifically was to use this language of physicalism, this public language.
That makes sense. Okay, so this idea of language is really important for him, right?
Absolutely. And this ties into the whole linguistic turn that was happening in philosophy at the time.
Yeah, the linguistic turn. So what was Neurath's take on that?
Well, within the Vienna Circle itself, there were different views on language. Carnap, for example, he was more inclined toward this idea of language as calculus, like focusing on the formal structure and the logic of scientific language.
So language as this precise tool for expressing scientific ideas.
Yeah. But Neurath, he was more interested in language as universal medium. That's what he called it. And he saw language as this framework, this really encompassing framework within which we think, communicate, and interact with the world.
So we can't really step outside of language and look at it from some objective viewpoint.
Right.
We're always already in it.
We're always in it.
Interesting. And so this idea of language as universal medium led him to propose this idea of what did he call it? A universal jargon.
A universal jargon.
Yeah, that was supposed to be the basis for unifying science and distinguishing it from metaphysics.
Exactly. He wanted this public, empirically testable language that could be used to talk about science in a clear and unambiguous way.
Okay, so this universal jargon, was it supposed to be some kind of completely artificial, formal language?
Not really. He saw it as a mixed language that would include descriptions of things in space and time.
Right, the physicalist stuff?
But also the ordinary terms we use, even vague terms, as long as they could be publicly understood and empirically tested.
Okay, so as long as everyone knows what we're talking about and we can check if it's true or not.
Right. And this brings us to his idea of militant syntacticism.
Militant syntacticism.
Yeah, he was really wary of semantic concepts like truth and reference.
So, what words actually mean and whether they correspond to reality.
Right. He thought those were really difficult to pin down empirically.
So he was more focused on the syntax, like the structure of language and how statements relate to each other?
Exactly.
Okay, and I know he also had this famous list of dangerous terms that he thought philosophers and scientists should avoid.
He did, yeah. The Index Verborum Prohibitorum.
Right. And what were some of the words on that list?
Well, words like I, ego, substance, terms that he thought were really prone to causing metaphysical confusion.
So he was trying to purify the language of science and philosophy to make it more precise, to avoid these vague metaphysical terms.
And that really fits with his focus on syntax, He was interested in how we can construct a clear and consistent language for talking about the world.
Okay, so we've talked about his views on science, his views on language, but what about logic and rationality? What did he think those were all about?
Well, Neurath actually had an early and quite significant engagement with logic.
Really? I didn't know that.
Yeah, especially algebraic logic. He even did some work with Olga Hahn, his wife, that was cited by people like C.I. Lewis and Alonzo Church.
Wow, so his work in logic was pretty high level.
It was, yeah. He saw algebraic logic, particularly with its use of symbols, as providing this kind of unifying framework that really connected with his scientific philosophy.
Interesting. So even though he's known for his work on, the foundations of science and things like that, his background in logic was really important.
Absolutely.
Okay, so what were some of his specific contributions to logic? What kinds of things did he work on?
Well, he focused a lot on Ernst Schroeder's axiomatic system of algebraic logic.
Okay.
And he was really interested in things like the nature of equality relations, and how we understand the idea of commutativity in logical operations.
Commutativity meaning like A plus B is the same as B plus A.
Exactly. He was very sensitive to the role of underlying assumptions and how our choices of notation can actually affect the way we do logic.
Okay, so even in this really formal system of logic, he was pointing out that there are still these like human choices and conventions that we have to make.
Exactly.
And I know he was also critical of what he called pseudo-rationalism in decision-making.
Yeah, that was a big one for him. He didn't think that all our decisions, whether it's about scientific theories or everyday choices, could be based on pure logic.
Right, like there's no algorithm that tells us what to do in every situation.
Right, especially when we have to deal with uncertainty and incomplete information.
So what did he think we should do instead?
Well, he thought we needed to use what he called auxiliary motives.
Auxiliary motives.
Yeah, things like our goals, our values, practical considerations, and even chance encounters. All these things can play a role in helping us make decisions.
So it's not just about, following the rules of logic, but also about being aware of the context and all the other factors that are involved.
Exactly.
Okay, now this kind of leads into his whole critique of foundationalism in epistemology, which was one of his big disagreements with some of the other logical empiricists.
It was a major point of disagreement, yeah. See, after Kant, the logical empiricists faced this really challenging problem. How do we explain objective knowledge without appealing to any universal or necessary a priori principles?
Right, because they rejected Kant's idea of synthetic a priori knowledge.
They did, yeah. Yeah. And so logic became a really important tool for them to try and understand the structure of knowledge.
And Carnap, he tried to tackle this problem with his Aufbau.
Yes,
right.
Exactly. That was his big project, this attempt to reconstruct our entire system of knowledge from a really basic set of elements, which he thought were like our immediate experiences.
Right. So starting with like the most basic building blocks of experience and then building everything up from there.
Exactly. And Neurath saw this as a classic example of reductionism, atomism, and foundationalism.
So he saw all of these things as like the traditional pillars of epistemology, the things that people had relied on to try and create this secure foundation for knowledge.
Yeah.
And those were exactly the things he was challenging.
Exactly. He was really against all three: reductionism, atomism, and foundationalism.
Wow. Okay, so what were his main criticisms of these ideas? Like, why was he so against them?
Well, he had a couple of main arguments. First, he really challenged the subjectivism he saw in Carnap's reliance on phenomenal experience as the foundation.
So, like, focusing on our private subjective experiences as the starting point for knowledge.
Yeah. And he argued that if scientific knowledge is supposed to be intersubjective,
meaning like shared and verifiable by multiple people.
Exactly.
Wow.
Then talking about private experiences just doesn't make sense.
It's like you can't really build a shared system of knowledge on something that's only accessible to one person.
Right.
Okay, so that was one of his criticisms. What was the other one?
Well, he also famously used this thought experiment about Robinson Crusoe to make his point.
Ah, Robinson Crusoe, the guy stranded on the deserted island.
Yeah.
Okay, so how did he use that to argue against Carnap?
Well, he said, even Robinson Crusoe, alone on his island, still needs language.
To, like, think and make sense of his experiences.
Exactly. And that means that language itself can't be based on purely private experiences.
It has to be something that's, like, shared, even if it's just shared with yourself over time.
Right. You need some kind of shared framework of concepts to even make sense of the world.
Interesting. So even a solitary individual like Robinson Crusoe is still embedded in this web of language and concepts.
Yeah.
That's a really cool way to put it. Okay, so instead of this phenomenalist language that Carnap was proposing, what did Neurath suggest?
Well, he advocated for the language of physicalism.
Right, so going back to the observable world, the things that we can all agree on.
Exactly. He thought that provided a much more solid and intersubjectively accessible way to ground our knowledge.
Okay, and this whole idea of language and knowledge, I know it's also really connected to his views on protocol statements.
Yeah, protocol statements were a big point of debate within the Vienna Circle.
And they were basically like these statements that recorded the results of our observations, right?
Yeah, but there were different interpretations of what they were and what they meant. Carnap, he had this idea of atomic protocol statements.
Atomic meaning like really basic, indivisible units of information.
Exactly. And he thought these were just reports of immediate sensory data.
Okay, so like I see a red patch or something like that?
Right. But Neurath disagreed with this view.
Oh, really?
Yeah, he thought protocol statements were actually much more complex than that.
Interesting. So what did he think they should include?
Well, he thought they should definitely include a core that describes some observable event, using the language of physicalism.
Okay.
But then they should also include information about who made the observation, when and where it was made, and even a statement that it is a statement.
Wow. So much more than just a simple sensory report.
Right. He wanted to capture the whole context of the observation.
Okay. And I know he also famously argued that these protocol statements were revisable.
He did. He thought that even our most basic observations could be wrong.
Right. We can always make mistakes.
And that's where the whole ship at sea analogy comes in.
Ah, yes. The ship at sea, one of his most famous ideas.
It is. So he said, imagine we're on this ship at sea.
Okay.
And the ship starts to leak.
Oh.
Right. So we have to repair the ship, but we can't just take it out of the water and start over from scratch.
Right.
We have to fix it while we're still sailing.
Okay, so how does that relate to knowledge and protocol statements?
Well, he's saying that our knowledge is kind of like that ship. We're always making new observations, gathering new information, and sometimes that new information clashes with what we thought we knew.
So we have to adjust our beliefs.
Exactly. And we have to do it without having some perfect foundational starting point.
Right. So there's no dry dock for our ship of knowledge.
No dry dock.
We're always at sea.
Always at sea.
That's such a powerful analogy.
It is, isn't it?
And it really highlights his anti-foundationalism, right? The idea that there's no absolute, unquestionable basis for knowledge.
Exactly. And this was a major point of difference between him and people like Popper and Schlick, who were also trying to figure out the foundations of knowledge.
Right. They had their own ideas about basic statements and affirmations.
Yeah, but Neurath thought their approaches were still too focused on finding some kind of fixed starting point.
He thought they were still trying to get back to that dry dock.
In a way, yeah. He was much more comfortable with this idea of knowledge as a constantly evolving, self-correcting system.
Okay, so that's his epistemology, his view on knowledge.
Yeah.
But he was also really passionate about the unity of science, right?
Yeah. It wasn't just some abstract ideal for him.
So what did he mean by the unity of science, and why was it so important to him?
Well, he thought it was essential for a whole bunch of reasons. Like, it would help us make better predictions. It would help us achieve more agreement among scientists. It would foster cooperation between different scientific disciplines. It would help us distinguish real science from pseudoscience.
So it was really about improving science itself.
Absolutely.
And making it more effective in the world.
Exactly.
And how did he think we could actually achieve this unity?
Well, he looked back at historical attempts to unify knowledge, like Leibniz and the Enlightenment Encyclopedias.
Right.
And he argued that we needed unity both within individual sciences and between different sciences.
So not just unifying physics, but also unifying physics and chemistry and biology and so on.
Yeah.
Okay, so how did he envision that actually working?
Well, he emphasized what he called a cooperative division of labor among the sciences.
So not trying to reduce everything to one fundamental science, but more about scientists working together.
Exactly. And he proposed this encyclopedia model for how science could be unified.
Encyclopedia model.
Yeah. It was this idea that science is like a giant encyclopedia with all these interconnected entries.
Okay, so not like a pyramid with, physics at the bottom and everything else built on top of it.
Right, not a hierarchy. More like a network.
A network. I like that.
And the links between the entries in this encyclopedia would be created by the universal jargon of physicalism.
Ah, so that shared language would help connect the different sciences.
Exactly.
Okay, and then this encyclopedia of scientific knowledge, it would be constantly growing and changing, right?
It would. He saw the history of science as this ongoing process of rearranging and integrating the different parts of the encyclopedia as new discoveries were made.
So it's a very dynamic, evolving view of knowledge. Okay, so we've covered a lot of ground here, but there's one more area I want to touch on before we wrap up. How did Neurath apply his ideas about physicalism and the unity of science to things like psychology, education, and the social sciences?
Well, he was pretty consistent in his commitment to physicalism, even when it came to those areas.
So he thought that psychology should also be based on this physicalist framework.
He did. He was really critical of concepts like the unconscious mind and any talk of purely subjective mental states.
So he wasn't a fan of Freud?
Not really, no.
Okay.
He thought that a scientific psychology should focus on observable behavior and physiological processes.
So a more behaviorist approach.
Yeah, you could say that.
Okay, and what about education? I know that was a big part of his work in Vienna.
It was. He had some really interesting ideas about education. He emphasized the importance of argument and discussion, of making complex ideas simple. and of using visual aids to help people understand things.
Right, like the isotype system.
Exactly. He really wanted to make knowledge accessible to everyone.
And I think he saw education as a way to create a more just and informed society, right?
Absolutely. He thought it was crucial for promoting cooperation and understanding between people.
Okay, and then finally, how did he view the social sciences?
Well, he thought that the social sciences could be genuinely scientific if they focused on events that are located in space and time and that we can publicly observe.
So things like social interactions, economic activity, political
Yeah,
movements.
all those things. He was really interested in how we could use the tools of science to study and understand these complex social phenomena.
Okay, but I imagine he also recognized that studying society is a lot different from studying, atoms or
Oh,
planets.
yeah, he definitely acknowledged the challenges of social science research.
So what were some of the things that he thought made it so difficult?
Well, he pointed out that we often have to rely on generalizations about groups of people rather than individuals, and that social conditions are constantly changing, which makes it hard to make accurate predictions.
Right. Societies are much more complex and dynamic than, say, the laws of physics.
Exactly. And he also talked about how our language for describing social phenomena is often vague and imprecise.
Yeah, like what does it even mean to say that a society is just or fair? Those are really complicated concepts.
They are. And he called these vague, clustered terms Ballungen.
Aluminum.
Yeah. And he said they make it really difficult to make precise predictions about social phenomena.
Okay, so he was aware of these limitations, but he still thought that the social sciences could be valuable.
Oh, yeah, absolutely. He thought they could provide us with important insights into how societies work and how we can make them better.
Right, and that kind of brings us back to his whole idea of the social function of knowledge, right?
Yeah, he saw knowledge as something that should be used to improve our lives and create a better world.
And he even had some interesting things to say about the role of values in social science research.
He did. He followed Max Weber in thinking that our values can influence what we choose to study, but that we should strive to be objective and unbiased in the actual research process.
So our values can guide our questions, but they shouldn't distort our answers.
Exactly.
Okay, so we've covered so much ground here. It's amazing how much this one guy contributed to so many different areas of thought.
It is. He was a really prolific thinker.
Okay, so for our listeners out there, especially the philosophers, what are some of the key takeaways from all of this? What are the big ideas that Neurath left us with?
Well, I think one of the most important things is his vision of a unified science
Yeah.
grounded in this physicalist language.
Right, this idea that all the sciences are interconnected and that we can use this shared language to talk about them.
Exactly. And then, of course, there's his critique of traditional foundationalism.
So this idea that knowledge doesn't rest on some absolute certain foundation.
Right. And I think it's really important to emphasize that his alternative isn't relativism, like anything goes. He's offering us a more dynamic and holistic way of thinking about knowledge.
A way of thinking that acknowledges uncertainty and the fact that we're always revising our beliefs.
Exactly.
And I think his emphasis on the social dimension of knowledge is also really important.
It is, yeah. He was really ahead of his time in recognizing how much our social context shapes the way we know the world.
Okay, so those are some of the big ideas. But what about, the so what? Why should our listeners care about any of this?
Well, I think Neurath's work can really help us understand the nature of knowledge itself and how it's connected to our social and practical lives. And it can also help us be more critical thinkers, more aware of our own biases and assumptions.
And maybe even more humble about the limits of our knowledge.
Right. Like we're all on that ship at sea together, trying to make sense of things as best we can.
I love that. And on that note, here's a final thought for our listeners to ponder. If knowledge is really as social and revisable as Neurath says it is, how does that affect our understanding of truth and objectivity?
Especially in a world where we're bombarded with information from all sides.
Exactly.
Yeah.
And how can we navigate this sea of knowledge without getting lost or shipwrecked?
That's something for all of us to think about.
Yeah. And maybe exploring Neurath's work in more detail can help us find some answers.
I think so.
All right. Well, on that note, we've reached the end of